Welcome to video number 13. This video is all about Zeno's paradox. Zeno's paradox is all about Achilles and a tortoise that we're going to have a race. And so just to help you visualize this, I've got a monkey to represent Achilles, and for the tortoise I've got a tortoise. This tortoise's name is Logo. He's willingly involved, honest. And in this race, Achilles, being 10 times quicker than the slow tortoise, says to the tortoise, I'm not sure what language he said this in, but he said, why don't you have a head start? So he gave the tortoise 100 metres head start in this race. Now I don't know how long the race was, but they started running. So Achilles sprinted to where the tortoise was. And during that time, the tortoise had moved forward a little bit. Not the 100 metres that Achilles just sprinted, but a tenth of that, he moved forward 10 metres. So the tortoise at this point is still ahead of Achilles. So Achilles continues sprinting, and he sprinted the 10 metres to catch up to where the tortoise was. Logo, the tortoise, he would then have travelled another metre forward. And this continues on, so Achilles would sprint a metre, the tortoise would go forward 10 centimetres, and it'd keep going. And the paradox kind of demonstrates how, if you're not careful about how you think about these problems, these things never actually meet. In fact, the argument would be that Logo, the tortoise, who is considerably slower than Achilles the monkey, would win the race, as Achilles could never get past him. Now, we know this isn't true. We know that this tortoise would have been beaten by Achilles. And the same problem comes up in mechanics too. Some of my students have problems getting over the same thing that Zeno said in his paradox. And the question that we refer to is in mechanics 2, where a ball is dropped and bounces and has a particular value for the coefficient of restitution, maybe something like 0.5. So each time it bounces, it's coming back with half the speed, and they have to find the total distance travelled, or the total time taken for that distance to be reached. And we have this kind of dilemma. Students can't say, well, if it never actually stops, then how do we work it out? And the reason we can work it out is because it forms a geometric series, which you'd see in C2, if you're doing Excel maths, for example. And geometric series are quite easy to use. The proof of how they work out, if you're trying to find the last point, is quite quick, quite easy to understand as well. And the standard results are really short. So, with that in mind, Logo and me are wondering, I've just got a lovely diagram here to remind you of the numbers. I'm wondering if you can work out how far down from the start of the race would the point where Achilles and Logo actually meet. Where would the monkey catch up with the tortoise? So have a go at working that out. Obviously, if you have done A-level maths, then this will just be a nice contextualised question for you. If you haven't done A-level maths and you're someone that's starting doing A-level maths next year maybe, then this will be a nice start to looking into some of the results you'll learn over the next couple of years.